Our next demo is from SkyFoundry. SkyFoundry's SkySpark analytics platform automatically analyzes data from building automation systems, metering systems, and other smart devices to identify issues, patterns, deviations, faults, and opportunities for operational improvements and cost reduction. Here's SkyFoundry partner, John Petsy. John, take it away.
Thanks so much. Well, I appreciate the opportunity to be with everybody today. And what I thought I'd do is try to dive in and demystify the whole concept of analytics. We've seen how it can be used in different products. And let's just talk about some of the ways analytics are actually used by people who operate facilities. So I'm going to do a quick demo in my 15 minutes. I'm going to take you through a series of views that an operator would have. So we're going to start here. This is a dashboard with a number of apps, and we're going to focus on this app here. And with SkySpark, the Spark app is where operators go to see what's been found by the analytic rules, the algorithms that are continuously running against the data to detect patterns, to detect faults, to detect deviations, anomalies, etc. So if we click on this icon, we'll be brought right in to this view here. And this view has a few simple controls where we can pick an individual site we want to look at if we're responsible for multiple sites. But for our demo here today, let's just say I'm going to pick my whole portfolio. I happen to have 8 buildings, and I pick that, and what I get is a view of here are the patterns that have been found in your data for today up to the last data you have available, right about looks like about 1:45 p.m. So what we're seeing here are the patterns in the data, and let's just take a quick look at what we're so we understand what we're looking at here. So in the first column, we list the site name. It's a common way to organize. The next column tells us, hey, what analytic rule found an issue? Here's a simple one that can often be associated with a lot of money. Lights have been running outside of occupancy schedule. They've been overridden. Then it tells us, well, what's the duration? And it gives us a visual cue with a bar graph. And then look at the next column, cost. The analytics can calculate the actual cost impact of these faults and deviations. You can attach cost factors from a variety of simple factors just based on time to complex factors actually based on complex energy rates, tariff rates from the utility company. And then we see the pattern. Here's the pattern of behavior, right? When the lights were running outside of an occupied period. So basically today from midnight up to 10 a.m. And then finally, we need to know which piece of equipment that was detected on. And that's what the final column tells us. It tells us that was the Carytown site main lights where that was detected. So what we're seeing here in this view, which is automatically generated by the software, is a quick visual indicator of what the problems are, where they are, how long they last, exactly what time they occurred in, which equipment they're associated with, and even the cost. Now, a lot of issues that you detect are immediate, but there's lots of analytics that form over a period of time. And what I want to do is I'm going to go back in time in these facilities, and I'm going to look at last month and see how we could look at an entire monthly view of our results. So again, we have our sites, we have our rules, our durations, we have our costs. Hey, there's a big cost here. We've correlated our tariff rate to our energy consumption, and look at that, we went above the penalties in our tariff rate, most likely on demand. We could look at that later, and we can see all the periods of time where we went above our demand limit, right? You can see all of those there. And notice when we look at a day, our cursor kind of snaps to an individual day, but it still shows us the relative frequency, repetitiveness, duration of the issue. Well, let's go down to a more detailed issue here. And I want to get down to the Gaithersburg site here, and 6 different issues, 1, 2, 3, 4, 5, 6, 7, 8, 7 issues were detected in the month of March in my Gaithersburg site. And I can see a whole bunch of them, but I want to drill into one of them. And I'm going to make that easy. I can just click here on the site name and I'll sort of filter down to just that information, right? Because if I had a big portfolio, I could have lots of sites and lots of these issues, which we call sparks. And if we look at this, we see all of the sparks. And here's the one I want to take a look at, right? This is actually the result of a fairly sophisticated algorithm. And we can click on the information button. And that gives us the help. It tells us what the issue's about, and you'll note it also gives us recommended actions. Because what you can do with the rules is many of the rules, you'll know what should be done if that fault is detected, right? So you can provide detailed instructions to your operators like we're looking at here. But let's review the help to get insight about this rule. And when it says the damper should be closed, and by that we mean it's looking at the control signal from the building management system, and it's at 0 or minimum position. But the temperature differential being seen between the mixed air sensor in the unit and the return air sensor is exhibiting a pattern that can only happen if outside air is coming in. So in other words, it looks like it's closed when we look at the screen of the BAS, but it's not. Outside air is coming in. So what might we do? Well, some examples. We might want to see if the damper control signal was oscillating. Maybe we have a hunting loop, right? We might want to see if the damper was overridden, commanded open, right? Perhaps they installed new carpet and thought it'd be a good idea to flush the space with fresh air, but did they ever put it back to automatic? Or maybe we need to get a ladder and go up and look at that unit because maybe the linkage is broken or stuck, or maybe, as is a real world case, there was a dead bird stuck in the louvers that prevented them from closing down, even though the control system signals it to close. So that's the description of the issue. Now, when did it occur? Well, we notice this one is occurring a lot, right? It continues to repeat. We've got Monday, the 1st, we've got the 3rd, we've got the 13th, we've got the 30th, the 31st. We're having this is a reoccurring problem, right? And it also tells us where it's occurring. It's on Gaithersburg RTU1, rooftop unit 1. So think about how much information we know. And again, I want to stress a key point, which is that all of these views that I'm showing to you are automatically generated by the software. I didn't have to assemble these or, like you would with a graphic in a control system. But this is helpful, but, I really want to know more. So I can simply click on any one of these, and the system, what the analytics does is it interprets the relationships between the data, the equipment, et cetera, and it gives me options. And the first option, it basically says, John, you can go look at that date across your portfolio. And we might want to do that if we want to see, is this a common problem? Or we could drill into the site, or we could jump all the way down to the equipment. But let's take this step by step and go to the site. So when we click here, we're now looking at that date, March 1st, in the Gaithersburg site. We see the issues we've had on that day. Happen to be 6 of them, but let's stay focused on this one. The outside air damper is stuck open based on the definition of that algorithm or rule. And now we see the exact pattern of behavior. We see that it was detected at 4:28 p.m. And it lasted until 5:10. And then it went away and it came back again at 5:33. But here's what's interesting. What else can we quickly see? Well, the answer is correlation. We can see that 2 of these things seem to be happening simultaneously. Now that could be an indication of the root cause, right? Maybe that's the root cause. What is that? That's short cycling between heating and cooling. Well, it could be the root cause, but I need to know more. So I'm going to click and I'm going to get my option to go down to what we call the equipment details. And again, all these screens are automatically generated by the software. The analytics software now is smart enough to assemble all these views. And when we click here, we're brought to the detailed equipment view. Well, what do we get? At the top, we get a much higher resolution example or line of the patterns that have been found. We more clearly see the start and stop time and their close correlation. But then the system goes and gets everything that's relevant to the issue. So what's relevant? Well, where did we detect it? We detected it in the Gaithersburg site. So let's get the weather from the local weather station, because that might have a bearing on the issue. It might not, but it'll be good to have it here for us to view. And let me show you another neat feature here. We can do a split screen so that we can frame the spark lines at the top as we scroll through all the other data, right? So we see our weather, and then we see the sensor data from the piece of equipment, RTU1. We've got our discharge return, zone temperature, zone set point. And then we've got our outside air damper. Remember, one of the recommendations was to look at this to see if it was oscillating or if it was overridden to 100%. And we can see there it's flatlined at 5% all day. All right. So the control signal thinks it's closed. We get our discharge pressure, and then down below, we get timelines showing the actual operation of the on-off points in our system, right? We can see that the building went occupied right here, 9 a.m. And as we'd expect at 9 a.m., what happened? Well, the fan turned on. But look at what else we can see in the data. When the fan turned on, 2 stages of electric heat started simultaneously. We can see they started together. There was no soft start or staging. Now, as the facility operator, I look at that and wait a minute, that doesn't look right, right? Our understanding is that all of our units are programmed to soft start, only bring on the first stage of electric heat first, and then if you can't maintain load within a certain amount of time, bring on the second stage, right? To manage our energy demand. But what are we seeing here clearly? We're seeing that they both came slammed on at the exact same moment in time. And I want to point out an interesting thing about this. That pattern that's being visualized for us, I didn't write a rule to even look for it, right? Big part of what we're doing with analytics in SkySpark is showing the correlations, the relationships visually to operators, which gives them immediate insight into, hey, this is not right operation, it's not proper. In other words, maybe we should add a rule to look for that. And of course, that's a rule that we have in our library, but we wanted to demonstrate that conversation. So we could see, how the day played out, how, the equipment operated. But let's go up to when the heat turned off right here, because that's when the problems were detected, right? Right there at about 4:27 p.m., right? And 2 things are happening. The damper's stuck open, we're having short cycling. And in fact, we see the evidence of one of the problems right here. Here we are, we've been in the middle of a heating day, and cooling stage 1 turns on from 5:15 to 5:31, 16 minutes of cooling in the middle of a heating day, followed by what? Followed by slamming on 2 stages of heat simultaneously, even though the second stage of electric heat will only stay on for a minimum time, potentially creating demand peaks if I have many, many zones in the building that are all operating this way. And we show you that with another one of the apps we won't have time for today. What we want to focus on is kind of the identification of an issue to the resolution. So I've drilled down, I see this, and I go, yeah, this is a real issue. We've got to assign somebody to it so that we can drive it to resolution. Now we've got a number of tools we can do that with. We can export any view in the system in a whole variety of formats. I could attach it to an email, maybe email it to a technician or an outside service firm, right, in all kinds of formats here. But you know what else we can do? We can immediately right here create a work order. That's what we can do right here with this button. Right? And we can add what we call an arc, and we use that term because what we're talking about is the arc of the life of an issue. So we said add a new arc, and it's immediately filled in the name of the equipment, but I can further add information to help. I'll say damper operation issue. And there's numerous types of tickets. There's notes where you just want to notate, put a notation on something. There's a ticket and a work order. I'm going to create a work order on this, right? And I can further refine that. I can add labels. Maybe I consider this as an HVAC inspection issue at this point. And I see what equipment it's related to. Next, I may want to assign it to one of my operators. So one of my operators are technicians, I'll assign it, and I want to put a due date in there. So let's pick a due date off the calendar. Maybe we want this addressed by Monday. And then we can add descriptive information, right? So maybe we want to add some information. Damper shows pattern corresponding to be stuck open, etc. And this is a dialogue we can have, kind of like a complete social media dialogue back and forth after we've assigned it to this user. So we click on that, and we have now created a work order. And here it is with the text, with all the tags. And here's what else is important. It always maintains the link, which will take us right back to the issue so that we can see that. Right? So what we've done with, if you think about it, with just a couple of clicks, right? We've drilled down all the way to the full equipment details on an issue that was automatically detected by the analytic rules that are running against your sensor and equipment data. We've seen the view, We've added a work order to it. We can export the view if we want to share this with somebody else and say, hey, look what I found, take a look. We can export it in a PDF format or any other format. So in just a couple of clicks, we've gone down and we're taking the issue from identification to resolution. And we can move right back up to the portfolio level. We can click here to come back to the site for the day, back to all of our sites for the day, or choose any period of time that we want to look across our portfolio, across individual pieces of equipment, so that we can understand exactly how our systems are really behaving. Now, this is just one way we can present information with SkySpark. By SkyFoundry, we have a whole series of apps, including a energy suite for energy analysis, a KPI tool for tracking your key performance indicators, calculating them, tracking them, plotting them over time. We've got a general purpose historian, so you can slice and dice and compare data and use a whole variety of different display tools and widgets to display your data in a variety of ways. But I think that brings us up on our time here. And so I'll stop there, and we can see if there are any questions that we can respond to. Thanks.
Great, thanks, John. So before we get started on some of these questions, SkyFoundry is giving away a $50 Amazon gift card. If you want this item to be yours, please comment SkyFoundry rocks in the chat box. We'll do the drawing after the Q&A.
All right. Well, I see a couple of questions there. Can I jump right in?
I can actually read them off, and then if you just like to answer them, does that sound good?
That sounds good.
Alrighty. So I have one here. It says, how does clustering work with SkySpark?
Yeah, that's a good question, and it keys right off of Alper's presentation. Alper, one of our OEM customers, who's building analytics technology into his products. So the concept of clustering means to connect multiple computing nodes together, and that's one of the unique differences of SkySpark, is that the analytics can be distributed. This is not just cloud-based. You can install it on premise inside the secure firewalls, behind, on the IT equipment of the customer. This is often required due to security requirements. And you can install it on small, low-cost devices, as you saw with BASSG's products there. It'll run on a small Raspberry Pi level device. But when you have all these different distributed computing devices, you need to connect them together. If you can think of it similar to the way a BMS system works, right? All these devices network together for coordinated control. Well, we're talking about coordinated data collection, analytics, et cetera. We have a secure, high efficiency communication protocol based on the IT industry standard called WebSockets. And you can connect these multiple nodes together. And here's what's key about that. When you connect them together, they form a seamless, unified system. So your operators don't have to worry about or know anything about it being, that they're on this node or whatever. It's all a seamless system for the operators. So, all right. I don't know if there's any other questions there. We answered one. Thought there was another question, but
Yes, I'm trying to look through here.
I think somebody had a question about how you connect to the BMS. But I think it got erased or deleted somehow.
Yes. All right, the clustering, we just answered that question.
It's in the dismiss column, how to connect or integrate with BMS. Let me try to quickly answer that.
Yes, sure. So I'll go ahead and just read it out so everyone knows.
Thanks.
How to connect, integrate it with the BMS and disconnect it from the BMS. How much effort will be needed from the controls contractor and or IT for either task?
Okay, so let's start with the first part. How does SkySpark software connect to the building systems, the devices, to get data? Well, it supports all these standard protocols. They're all built in. So it supports BACnet IP. It supports the Project Haystack API. It supports direct connection to existing SQL type databases. So if you have a BS system with a host software that has the data in the database on the host. You can connect that way. SNMP, that's a protocol for IT equipment. OPC UA is industrial equipment. Modbus is extensively used with meters. MQTT is a standard in the IoT industry. Portfolio Manager, that's by Energy Star, so that SkySpark can report the data. It also supports Obix and Sedona. So the point is it can use these standard protocols to get the data. As far as disconnect it, you can connect and pull the trend logs out and disconnect if you want to, or you can sync the data regularly. You can stream the data in near real time. You can update trend logs. So there's lots of ways to connect to data. It doesn't demand a live permanent connection to your data. As far as involvement, if the system can be connected and the owner has the password to connect to it, then you wouldn't need involvement by a controls contractor. If for other reasons you did need the controls contractor in there to get permissions or an account set up. As far as IT, that would only come into account on any type of security issues that you need to work with, and that would be very dependent on the individual organization. But SkySpark supports those connectors directly in the software.
All right, so we have one more question here. It says, can equipment data be stored for long periods of time effectively?
Yeah, absolutely. That's a key part of our high performance database capability. It's highly efficient in storing what is called time series data. That's what we're talking about. We're talking about a sensor value, a temperature sensor, 76.2 at a moment in time. And so you can store years and years and years of data in very small amount of disk storage space. For those who are a little bit technical, we can store a time sample sensor value in approximately 12 bits. And you can compare that to conventional technologies take 30 or 40 bytes to do that. So yeah, we have people who store vast amounts of data. For example, the GSA Link project uses SkySpark and they onboard over 50 million data samples a day and they keep it all.